Hi, everyone. Thank you for joining today our webinar. As Samuel said, we're going to tell you how we do safety analysis, but this time not the classical safety analysis, but using Capella. Okay, we have developed a plugin, and we're using this plugin to improve our analysis, and we're going to tell you our experience. Okay, first I want to share with you which is our company and what we do. Okay, and we are Anzen. I think many of you already know us, but well, we are really focused on system safety and reliability analysis. So we have several teams around the world, Switzerland, USA, Europe, Germany, the UK. Okay, but we have a big team, and we have then one team, my team, which is focused on digital engineering tools. Okay, our work as a digital engineering engineers is to support ATICA users. Obviously, we do software development. Fernando here, he's a software engineer. We do consultancy as well to other companies that are dealing with the same problems, same challenge than us. And then we also participate in research and development projects. Okay, we also have other areas of interest like the ILS, integrated logistics support, hardware and software assurance, certification, and cybersecurity. Okay, today we're going to be really focused on the first two ones, safety and reliability, and model-based systems engineering, or model-based design, or well, Capella. So yeah, what are the outcomes of this webinar? Well, first, I want to make sure that you understand the advantage of using an MBSE approach. I'm going to tell you why. We want to share our experience in developing ATICA because it's a bit different. We have to deal with software, code, then we have to map some concepts into the Capella ones. We want to explain to you how we did that. We then will showcase ATICA capabilities, and we'll do a live demo at the end of this webinar. And then we want to offer Anzen expertise to companies with the same challenges than us, so we can help them to speed their adoption of digital engineering tools. So yeah, this is the index. First, I'm going to explain when the timeline of the development of ATICA, because that didn't happen overnight, and we've been for a while in this world. Then I'm going to go to the why, the reasons why a company working on the safety and reliability analysis now that do this kind of things. So I'm going to tell you why, and then finally we're going to see how we do all this, and we're going to see the live demo. Okay, so this is the timeline. Anzen was founded in 2019. We just celebrated our 5th anniversary last year, but the first digital engineering project was in 2020. We started using the ESA Compass. It is a tool, maybe some of you already know it. After that, in 2022, we started with ATICA. Back then, ATICA was just an idea, but it was awarded with a prize, and we get some fundings to get it started. So after 1 year of work, in 2023, we released it publicly. And then we did a webinar, okay, a Capella webinar. We work with FHA, a company who is supplying a system for aircraft and other platforms. And with that activity, we did a Capella dates webinar. Okay, you can check it out, and it is worth giving a look. And 2024, we started CORSARIO. CORSARIO was the first commercial real project in which we applied Capella, ATICA, sorry. And it finished in mid-2025. You can check it out in our blog. We have several publications. And in 2025, we started the Anzen project. We're going not to talk about it today because it's a bit out of the scope, but well, we are planning how ATICA or how can we work with newer platforms and languages like SysML v2 and the APIs and that, but it is another part. Okay, So yeah, this is the when. So let's see why we use ATICA, why we get into this. But first, because ATICA made our life easier, you're going to see how. Then I'm going to jump to the process of safety and reliability in ATICA and the standards used, because the standards is a very recurrent questions, and I want to address it today. So yeah, this is the usual workflow in systems engineering. I would say we have on the left the requirements that guide the design. Then we have an engineered system that is, it has functions and it has an architecture, and this system exhibits certain quality characteristics. Quality characteristics are what we could call ELITs: reliability, safety, maintainability, security. Okay, we're going to focus just on the reliability and safety today, but there are many more. And these quality characteristics give us, as a safety engineer, some feedback that we are going to use to fit the requirements, and at the same time guide the design again. And this loop can be done over and over again. If you work in this sector, you notice it in your daily life. The things are quite easy when you just loop once, and it is done basically in the systems that are very simple. But when your system becomes really complex, you can do it twice, 3 times, 10 times, 100 times, and then the things become really, really hard to handle. And we need to use new kind of tools, because Word and Excel are good for many things, but when you have to manage complex things, it becomes quite difficult to have everything in line, well tracked, updated. So that is what we have been really, really focused on with ATICA, to have all things together. The good part is that quality characteristics, it doesn't need to be verified at the end of the process. You can do it at the first part of the process. So you can shift your process to the left. If you see the V cycle, you can put it at the beginning, and you can provide early feedback to your systems engineering team, and finally you're going to make it everything easier, and spend less money, time, and resources. So these are the 3 main points. The first one is we're going to use the same surface through that the systems engineering team, which is a great advantage. I don't have to spend time reading the systems engineering documents. I have a model, which is the truth on the actual model, the most updated one, and I can take that for granted, okay, because it's just the same. The second point is that I can impact, as a safety engineer, I can impact directly to the design by putting my requirements in the same database than the systems engineering. And then I can anticipate, that was what I just said, I can anticipate safety risk at the very beginning of the process, and then I can therefore save time and money, which is a really good advantage. And these are the advantages, but getting into digital engineering, to MBSE, is difficult. It's not, you can do it from one day to another. And we have gone from the one part to the final, and we have learned that we need first to learn how we can do it, then we can need to implement it, and finally we have to teach others how to use it. So this is the part where Anzen can help other companies. We have done this travel before and can help new companies to do it fastly and get directly to the point they need to be. And this is the standards. A lot of companies ask us about what standards do we implement in our tool. And this is quite simple. We just went to the ARP 4761, which is called also in Europe ED 135. It is exactly the same as the 4761, and we took the standard and replicated it into ATICA. We didn't reinvent the wheel here. We just used the truth, which is the standard, and use it the same way as it is expected. Okay, you can see here the FHA table. We just replicated it. It can't be done in the same way. We have to tweak little things, but this is just mainly format. But believe me, it's just the same as the standard is. So how we did this? Okay, so we have the standard from reliability, safety, and then we have concepts and analysis. The concepts are the definitions, and we mapped those definitions into the meta model elements of Capella. You're going to see it in a minute when Fernando shows it to you, to all of you. And then we have the analysis. The analysis are mainly tables, diagrams like the Fault Tree Analyses diagram. We just took every concept and every analysis and give it a place into the meta model and the representations inside Capella. That's why ATICA does. Okay, we move all these concepts into the Capella thing. And this is the full picture. Okay, we have the typical Capella elements and the layers, system function, logical component, physical component, and then we add some new concepts: failure condition, effects, severity, failure rates, failure modes, etc. And at the same time, we add some representation: FHA, failure hazard analysis, FTA, fault tree analysis, FMEA, etc. Okay. They are pretty the same. They are interconnected, one layer with the other. So if I change something at the very top level, it's going to replicate at the low level, and vice versa. And then we add several instruments to facilitate certain tasks. Like in the EPBS layer, we add a bill of materials importer. We pre-configure some failure modes to just to make the piece part FMEA more easier to do. Okay, and well, be more efficient because there are many tasks that are replicated over and over again. And when you use this kind of tool, you can take advantage of the automatization of the tool itself, and you can just code it to be replicated forever. Then you have some stakeholders that don't use Capella, okay, because they want paper, they want PDF documents, and that. So for those stakeholders, we created some templates, M2Doc templates. M2Doc is a tool, a plugin for Capella that allows you to take your information from the model, in this case ATICA plus Capella, and extract all this and put it to a Word document. And we have a lot of templates. I put some examples here: system safety assessment, FMEA, bill of materials. But the good thing of that templates is that they can be used over and over again, and you can easily change the little tweaks for one project to another. So if I have to change the logo, I can change the logo very easily because the table is just the same. So we have found that it is really, really useful to work this way. And now I'm going to let Fernando to step in. He's going to show you the demonstration, and he's going to explain you the relationship between the different components, elements, and the representations, like the FHA. Go ahead, please, Fernando.
Thanks, Danny. And yeah, very briefly, thank you everyone for coming. Thank you to Samuel and the rest of the organization for having us. As Daniel said, I'm going to move more into the technical aspects. So here in this first image, you can see that the first layer of the ARCADIA method, the system layer, on the left of this figure, you can see the concepts that are already modeled in Capella. Think of these boxes as actual elements of the meta models, but also like a bit of a simplification. The underlying meta models are more complex than this, but this is enough to get a rough idea of what is happening behind the scenes. So, for example, you can see that for system functions, we have the concept of failure condition. As Daniel already explained, this is not something that we just came up with. This comes from the standards that we follow to develop ATICA. So one of the main concepts in the system layer for the functional hazard analysis is the failure condition, and this is related to other secondary concepts like the severity of the failure, the assumptions that you make, everything related to the stakeholders themselves, the effect description, and so on. So we created a model-based representation of all this using the whole Eclipse and EMF and Capella ecosystem to represent these as meta models, and then create our tools and functionalities on top of that. So for the system layer, the most relevant analysis is the functional hazard assessment, or the FHA. In this case, the S is because this is the one I will show you is for the system layer. So let me just jump into ATICA for Capella and show you how it looks. So you can see that the first thing is that we developed ATICA to try to integrate it as seamlessly as possible with Capella as we could. So there is not a different interface. There are not plenty new buttons laying around. The idea is that you feel familiar with it from day one. So this is a regular Capella project with the regular layers that you get by default when you create it. The example that I'm going to show you is the wheel brake system from the ARP 4761 that Daniel mentioned before, the one from the standards. So if we open the system analysis layer, we can see the familiar stuff that is always there, but there is also a new element for the things we add in ATICA. So, for example, in here, you can see that we created containers and categories to define failure condition types. So here we already have defined some of them for this example. The same goes for severity types. This is more or less standard for any functional hazard assessment. Of course, you create all these elements. Probably the easiest way to do it is with the contextual menu. So if you come here and you tell it to add Capella elements, you can see that you can add safety effects, you can failure types, the package themselves for ATICA. And most importantly, you can add failure conditions. To keep everything tidy, you can also put this in folders. So, for example, in this wheel brake system example, all the failure conditions are shown here. And then the other thing you can create is the view, the actual thing that your engineers will hopefully feel comfortable using, because it's the table that they normally do, as Daniel said, in Excel or in any other more document-based environment. So in here, you can create the FHA table. I'm going to show you the one that I already have created. It appears here in the corresponding package. So if we open it, you can see that this one, the key element is the system function, because, of course, we are representing our failure conditions associated to system functions. So from the different system functions and system sub-functions, we can create failure conditions. So, for example, all these that you can see here, you can also see them here related to the corresponding failure conditions. Again, if you want to create a failure condition from scratch, you can also do it from the contextual menu. So you could come here and create it like this. But again, after our engineers started using the tool, using ATICA, they came up with feedback. So we have things like the possibility of creating it from this contextual menu. So you can create systems and functions for a given system. But also in here, you can create a failure condition. So, for example, if I create it here, you can see that it appears already in the table. It will also appear in the Explorer. But because I created it this way, it already relates to the corresponding system function. If I open the details by double clicking it, you can see that, okay, the name is not set, the label is not set. I can do that from here, but already it's related to the function, let's say the parent function to where I'm associating it. And then in here, I can, for example, give it a name. But this is not the only possibility. I could also edit things like the label directly on the table. So, for example, if I want a different label, because I just want this to be called something like T1, I can do this here, and it works. The relation to other elements, like the failure types or the severity classification, the table already allows you to do it from the table itself. So in here, you see that you get this drop-down list with the values of the failure types that you already defined in the System Explorer. So I can easily set it here. The same goes for things like the severity classification. So from the severity types that I have defined here, I can just pick one and set it here. The assumptions, same idea. Here we have a set of freshly defined assumptions. This is a test one that can be deleted. All that is synchronized. As Daniel said, the idea of MBSE is that you have a single source of truth. So whatever you change, it changes everywhere. So, for example, this field is a bit more complex. So if I double click it, what I get is the table that I had before. And from here, I can, apart from the common tabs that you have in this kind of views from Capella, we have contributed new tabs. So, for example, this one for ATICA allows you to either create a system assumption, a safety assumption, sorry, like this one. So I can just associate it, and then it will show on the table. But I can also add it from the table itself. So I can here now safety assumption one with whatever summary, whatever value, and it's already created and listed. and it appears in a shortened way for clarity on the table. So this is the base idea. Your engineers, your safety and reliability engineers should feel comfortable using ATICA because it's a table, is what they're familiar with. The columns are the one from the standard. We didn't invent anything new here. We just made sure that it's integrated with ATICA and that you can see it with a, let's say, familiar feel to it. Okay, so now let me move back to the slides. This was the FHA. So now let me talk about the next layer in the in ATICA and in Capella, which is the logical layer. Same idea. You have your Capella elements on the left. So here, for example, Capella already had concepts and representation for your logical components, which is probably the main element in the logical layer, and your requirements. And this relates to the new concept that we created in ATICA. In this case, in the same way that the failure condition was probably like the main element in the system layer, for the logical layer, the main element is not only the functional failure, but the idea that the top event of a fault tree is associated to a functional failure. So you can specify or define a functional failure with the related fault tree. There are other things. There are things like local effects, assumptions, and therefore there is called the relation to your failure conditions. Again, this is just a brief idea of what the metamodel has. The metamodel is much more complex than that. But again, let me just jump back into ATICA to show you how the FTA. So again, we move now to the logical layer. In here, again, there is a package for ATICA. You can see that here we have two of the functional failures that can be identified in this wheel break system example. If I expand them, you can see that there is this other element, which is the top event of the tree. Again, the best and easiest way to create this kind of elements in ATICA is with the context menu. So in here, you could add your top event for the FTA from here. The important point is once you have the top event, you can stop working in this in the tree view, and you can just move into the representation for the tree. So in here, I have already created a graphical representation for this tree, and because it's a bit big, let me just put this window a bit bigger. Something that I didn't mention before is in the same idea that you can edit things on the tree view directly, the properties view of Capella also shows the same information, and it's already containing the extensions for ATICA. So for a given element, like for example, this gate, you can see the properties view, and in here you could edit things like the name. So if I come here and I say that this is not channel number 2, this is channel number 3, it already updates in the view. There are other fields with more internal stuff that are, because of time restriction, I cannot stop and show you. But yeah, again, you have the ATICA MBSE tab for your safety assumptions, safety studies, and so on. But an important point in here is that this tree view is not just a view, it's a full-fledged editor. That means that this is a tree that I can edit. So for example, if I want to create a new OR gate, let's say dangling from this AND gate, I can just do this and create it, or I can also use the palette that you have on the right. And here I have my brand new OR gate from which I can, for example, create a new basic event like so. The layout gets a bit crazy sometimes on the edge, but that can be easily fixed. And this is now a new part of the tree that I created. You can see that because this is an undeveloped event, it shows with the usual square or rhomboid shape. But an important thing here is that because this is model-based and everything is related to everything else, if I open the details of this element, apart from giving it a name and so on, I can associate it to a failure event, which in this case would be in our physical part a failure mode. I will later show you this in more detail in the next part. But the moment I associate it with a failure mode, because the failure mode has information about exposure time, probabilities, and so on, the moment I link it together, you can see that the failure rate already updates. And the moment I save these changes, you will see that this undeveloped event will change to a basic event represented with the circle. There we go. The probability and the failure rate updates. If something doesn't update, it's because I'm going fast and maybe I need to add exposure times and everything else. All these things can be done from either from the properties view or from the pop-up window. An important thing is that because I made changes on the tree, you can see that in several places this icon with the red kind of light appear. That's because I introduced changes to the tree. So if I now go to the top event and I recalculate, this probability will probably change. I think it will change with the changes that I do. So from 7.1 blah blah blah, it changed to 7.0, and now it tells me that everything in this part is updated. And the last interesting part of the trees is that we have transfer gates. You can see that some of these gates are triangles, and this is something you can navigate. So if I double click here, it opens the tree that this transfer gate is referring to, and everything is connected. So if I update some of the probabilities here, because that tree is linked to this tree through this transfer gate, it will tell me that I need to update the probabilities here. The probabilities change. All your calculations will work properly. When you calculate the cut sets or the minimal cut sets, it will work the way one would expect them to. And again, this is you can also navigate on the other way. So the fact that this gate in the top event has this small triangle is telling me that it's used in a couple of places. You can see the details down here. So if I click in one of them and I say OK, it will take me to the tree that is referencing that gate. Again, is it possible to do the usual things that you would expect? Instead of doing this basic event the way I did it before, I will do it directly, and it will already ask me, okay, what is the failure mode that you want to associate with it? I could also, if I wanted to hide part of the tree, because maybe this new part I did was messy, I don't want to see it for a while, okay, I can just hide it, and when I'm ready for it, I can just unhide it or show it. And yeah, everything works the way one would expect it to. Okay, and for the last part, now we move into the physical layer. Again, same concept and same principles as before. We have the Capella elements. In this case, we can link with requirements. We can link with the physical components that Capella already defines. And in ATICA, we created the failure modes that you briefly saw before when I linked this undeveloped event in the tree. These are related to the local effects they have, to the assumptions that you make, and to the functional failures on the layer before, on the logical layer. Again, this is a brief excerpt of the metamodel. It's more complex under the hood. The important thing is your engineer doesn't need to know about this because all they will see is a table. So this is the table for the FMEA, the Failure Mode and Effects Analyses. And yeah, I think I have time to give you a quick tour of how it looks. Before I forget, I want to say that we also have developed elements for the EPBS layer. As Daniel said before, we have a view for the piece part FMEA. We have also extended the metamodel in that regard. But because that is more complex, you have to deal with the bill of materials, importing elements. It's much bigger. It will be a bit more cumbersome to show. So I'm not going to show it in this demo, but suffice it to say, we have it. So if you think that is something that you need, worry not, because ATICA has you covered. And then, yeah, for the physical architecture, you can see that we have our functions. We have, again, a package for ATICA. But here now, there is nothing here because what we're looking for is in the structure. The FMEA, is related to the physical structure of your system. So here you can see that we have the different physical systems that you have, the control with braking, the actuator braking command. And in here, for this specific component, we have subcomponents and all that, but it's at this level that our engineer, in this case, this was Samuel who did it. Our colleague Samuel, Samuel Garcia. He's the one who put the FMEA here. So credits to him for this work. And here you can see that is conceptually it's a bit similar to the FHA that I showed you. So you have your structure. In this case, it's components instead of functions, and also subcomponents. And then eventually you reach the level at which you add the failure modes. Again, you can see them on the tree view if you want to. Or you can add them, better said, in the tree view if you want to. But the best way to do it is with the table. And in some cases, we have even hidden the options in the tree, because we believe this is much easier to do, because then also you have the properties view down here if you want to work with your element. If you let's say double click an element, you get everything that you can configure here. So for example, in this case, you could easily create, once you have the view, you could create a failure mode associated to a component. So if for this component I wanted to create a new failure mode, I can do so. Same as before, it's already linked to the component. So if I open the details, you can see that this affects component feature is already set to internal power one, which is the one that appears as the parent on the table. Same as before, I could go to the ATICA MBSE table tab, to add safety assumption and studies. I could mention if it's observable. In the failure causes and effects, I can do things like update the failure rate. That can be done both in the table or in here. So you can see that now it's the default 0 failure rate. But if I edit it and I write something here in scientific notation, so I can do something like 1 to the -6, it's updated in the table in red because it's something that I put manually instead of being calculated or deduced from the other elements that are linked in the model. For things like whether it's observable or not, I can easily set it in the table. I can, if I double click here, it will allow me to edit the failure modes. I can put the IDs because this is just a normal text field. If I want to relate it to a failure effect, then the tab or the corresponding tab opens as a pop-up window. So in here, you can browse your model and relate it to other functional failures in the logical part. We have done our best to ensure that you don't have to navigate all elements to find what you're looking for. So the elements that you see here are filtered by the ones which are relevant to whatever you are trying to establish. For example, for the failure causes, again, you could relate it to a failure mode in the physical, still in the physical layer if you want to link them to each other, and so on and so forth. So because I think I already used up all my time for the demo, I will stop here, but we have time later for questions, so I will be glad to explain or show any feature that you think I missed showing you. But that's all for now. I would like just to finish by saying that, as Daniel said at the beginning, we have several goals with this talk. One of them is getting you to know Anzen and ATICA in particular. So if something that you saw in this presentation looks interesting, relevant, or that it solves a problem that you have in your company, know that we offer both the product itself of ATICA for Capella, but also services. So if you want only the services, we have this option for co-engineering, when we can do gap analysis of the different frameworks and digital tools, help you select tools, train you on whichever tools you need. If you are already trying to adopt or already have adopted MBSE, especially if you plan to use ARCADIA, Capella, we can also support you to perform those analyses. On the other side, when it comes to the product, we have different licensing and distribution options for ATICA. So please reach to us if that's something you find interesting. But not only that, also, as you can see there, in the intersection of both, we also have tailoring. So if you like ATICA, but you think it's missing some crucial part for your needs, or if you feel that some of the views that I show you is missing a field or some functionality that you really need, we are open to improving ATICA or to creating a tailor-made version of it for your needs. But before any of that, if you also want to just see if ATICA is something that could work for you and you didn't have enough with what I just showed you, you can try it yourself. No charge, no strings attached, nothing at all. You can just go to this link, anzenengineering.com/digital-tools, or just scan the QR in there. And that will lead you to a small registration process. Don't worry, we don't ask for credit card or any personal or big details. Everything gets deleted. We only save your email to reach to you or to know if you need anything else. And yeah, you can try it from your browser. You will get the same Capella-based environment that you saw with all the buttons with this same Wilber system example. You can browse it, and after 30 minutes, well, you can extend it if you want, but if not, after 30 minutes, everything will be deleted. So don't worry about any, privacy or preserving, or that we keep what you did there, because it's everything is anonymous. We just want you to give you the easiest and fastest way for you to try ATICA for Capella. Okay, I think that's all. Thank you very much for your attention. Also, as I said before, kudos to Samuel Garcia, whose work was very important for this presentation, even if he's not presenting at the moment. Yeah, thank you to Danny, and also thank you to Samuel, Obeo, and to all of you for attending. If you have any questions, we are happy to answer them. And also we have our blog with the latest news and to give you an idea of what we're working on at the moment. Thank you.
Thanks, Daniel. Thanks, Fernando. We do have questions from the audience. When you presented the standards, you were talking about aircraft or aeronautics standards. What about the space standard, ECSS?
Yeah, I think I can address this one. Well, mainly our projects until now have been for aircraft and aeronautics, we will say. But at the same time, we are looking to expand into other sectors. And the space sector is a very similar sector than the aircraft one. So we think that it would be easy to replicate the same model that we have used for the aircraft. So this is something that we haven't done so far, but it is just a matter of intention. So if we want to do, we can do it the same way that we did with the aeronautics.
Okay, thanks for that. Next question. Is there a possibility to implement alternative safety analysis methodology with ATICA?
Yeah, same answer than the one before. Regarding STPA, we're planning. In fact, there is already a plugin for Capella for STPA. We're planning to expand. Okay, but we need partnerships, because we do this if we have a project that motivates. Okay, we don't do things because for the sake of it. We do when we have a really focused need, and that's what we are waiting for, and really looking forward to have new partnerships, new projects to work on. So yeah, it could be done, but again, it's not yet done.
Next one. Part of design assurance is being able to demonstrate that the logical and mathematical basis is validated. Is the ATICA code that handles the PF computation shareable?
Yeah. Currently, the mathematical computations are carried out by ATICA, but the plugin itself, the way that we are validating it is taking a set of tests, and then we validate that the tests are the same between different tools. So this way we validate that the computations, mathematical computations of ATICA are correct. We have also several corner cases. This is the way we validate the tool. We think that this is aligned with the ARP 4761 requirements. But yeah, this is the kind of question we always have from clients and partners, and this is really important to the design assurance. But well, this is the way we do it today. But we are open to see other things as well.
And I just wanted to mention that whenever possible, we are also trying to improve our methods for calculation. So, for example, right now we are also playing around with improvements to the FTA, the calculations we do related to the fault trees, to try to follow more closely, methods that are not only more formal but also more efficient and that can handle corner cases or don't even have corner cases precisely to address this kind of concerns.
Okay, next one. What formats can the FHA and FTA results be exported?
Yeah, well, there are several answers that can be said here. So you can export the FHA and the FTA, well, and an SSA, which is the addition of both, using M2doc with the templates, and you're going to export it to a Word document. This is way that we have found that it works. And then you can load data back into Capella, but not at that level. You can do it at the low level because what I said you before is that you can load a bill of materials. But anyway, for instance, for a project we're working on now, we have developed a custom importer for an FMEA. So it can be done. It's just a matter of doing it itself. So, and Fernando, correct me if I'm wrong, but the importer now can be somehow modified to handle a lot of different combinations, right?
Exactly, yeah. The idea is that you can import, in principle, if we extend it, anything in any format, right? So, for example, the importer that we have now is working with Excel because it's what our colleagues needed, but it shouldn't change much if suddenly you come with as a CSV or any format that can somehow be parsed by some algorithm, right? So yeah, the idea is that we can grow this eventually. Also, this is to soften the effort or the learning curve if you want to move into ATICA and into Capella in general, so that you don't have to take the document, let's say that is a Word document or an Office document that you already have, and start copy pasting or just putting everything by hand on Capella, but you just import it and boom, you get it for free, let's say, and then you can keep working there, but you don't have to, you skip that manual step.
Yeah, another thing we've been working on is connecting to APIs. So if you got an API who is providing you some information, we can connect and fetch the information directly from the API and fill the whole Capella and ATICA elements from the API. That's something very useful. We're looking forward to implement it seriously, but it's something that can be done and we're working on it. Yeah.
Okay, thanks for that. FTA and ATICA or where the computations of code sets and probabilities done?
Yeah, well, I said it before, it's inside ATICA, okay? Well, we have several design options here. We can do it inside ATICA, outside ATICA, and connect with an API, but we decided finally to do it inside ATICA for now. Who knows in the future? There's no interface tool for now. Everything is done in ATICA. Okay.
Okay. And for safety specialists, which failure rate databases are available to use?
Yeah. Well, any of them, because the thing is that we are not connected to the safety reliability databases. The way we do it now is we do the reliability prediction report with whatever tool, okay? Then we export it into a interface document or format, say Excel, and then we re-import it to ATICA. That's the way we're been doing it. But is it in our roadmap to increase our capabilities regarding that? And you'll have some news in the future because we've been working on this to connect directly ATICA to the reliability databases, because it is a really recurrent task and it is really a very time demanding task and sometimes error prone and that, and we know this is really important. So it is in our roadmap, not yet, but it is.
How does ATICA support safety and system engineers in proper adherence to the safety and system engineering process?
Yeah, this one I think could have been seen when I presented the standards. One reason for using the standard, well, I said we didn't want to reinvent the wheel, and we wanted to use something very standard, like the standards, okay? But another advantage of that is that you can make the engineer to adhere to the process by default. So the the tool is itself making the engineer going the way you want to do. That has a problem, however, because it complicates the flexibility, or it reduces the flexibility of the tool. So we are in a point in which sometimes we want more adherence to the process, but at the same time others want more flexibility of the tool, and this is a complicated, go and well, a play within the engineers, and that it is a difficult point to answer. But yeah, the way we obtain the adherence is by using the standards in the tool.
Yeah, and let me just quickly add that when it's in our hands, we actually try to enforce good practices. So, for example, this importer from Excel that we recently did, it doesn't give you any chance to say, okay, how would you like to represent the information for the FMEA table you have? No, it will turn into what the standards tell you they should turn into. So your functions will turn into functions at the appropriate level, and they will be related to the failure modes, failure conditions in the appropriate way, and that already gives you a solid and well done basis to keep working. So yeah, we try when it's in our hands.
Yeah, and I guess at this point, not everything is supported by the tool, but you're still able to provide support on top of this. So it's a good point for Anzen. Okay, so does ATICA have any features to deal with the multi-system safety analysis to make it more efficient and reduce redundancies?
Well, the thing is that, in my opinion, the multi-system, it's not, for me, just a personal opinion, it's not well defined in Capella itself, because you have the system layer in which you have your system as a black box, and then you have your logical level when you can open up your system and see the parts, and nobody tells you if that parts are subsystems or not. So the same applies for ATICA. So if you use for your Capella system to system transition, like the plugin that is on the internet, I think it's from Thales, you could do the same with ATICA, okay? But ATICA doesn't add anything to support multi-system or system to system level transitions. It's a complicated thing. It's something that I think it must be really tailored for the project or the company that it is applying the process. And I think I know it is can be a problem sometimes, but until now we haven't had the problem, or we haven't faced it directly.
Okay, how to use heritage from previous project?
Yeah, well, this is a really important question, because one of the advantage of using model-based, and you can reuse projects. So if two projects are very similar, you can make use of the previous project to create a new one, and save time and resources on that. But the question, the answer here is that it's pretty the same than the one before. We haven't added anything on Capella, on ATICA, that doesn't have Capella, okay? So if you want to use a previous project, the best way, I think, is copy-paste your previous project and do it from that point. You can use, I think there are variation models that you may use if you want to. But anyway, it's up to you and depends on the project. And the existing failure conditions are coming from, I don't know what failure conditions do you mean, Lea, but the example you saw here is just an example we did. They are not coming from any, just we invented, well, we took it from the ARP 4761 for that purpose, for the example purpose. But if you mean, I'm reading again the question, if you mean that if there is a database of failure conditions or something like that, we don't have such a thing. I don't know if that answers really the question, but you can write us and we can have a chat on that.
How do you consider the mission description during the FHA?
Yes, so you might have noticed that we have skipped the operational layer in Capella from the ARCADIA process. because we haven't found a really useful part on the operational layer, which I think is where the mission description goes. Anyway, when you describe your mission, you can describe your functions of your system, and then you can fail your functions to describe your failure condition. I think this could be the way you can handle this. Okay, consider the mission description, not at the same point that the operational layer, because it's different, the system layer, but you can somehow do it, I think. Anyway, again, if there is a special need for a project, we can tailor it because we've done it previously, and it is something that can be talked about and realized.
So last question here. Actually, there's more than one, but anyway, does your process implement a failure propagation model as mentioned in ERD 135? Is your process aligned with a lot of other standards?
Yeah, I'll take this one. I've read all them, and regarding the first one, we did it. If you see the previous webinar, 2023 webinar, you'll see some hints of failure propagation model, but we haven't found it useful so far for real industrial projects. Okay, we are using it for testing, academic projects. That's okay, but when it comes to industrial project, we stick to the FHA, FTA, FMEA process. Okay, classical one, I would call it. Second one, it is aligned, regarding the appendix we have talked about for the FHA, FMEA, and FTA. It is aligned with the latest review. And we are familiar with the coffee and interdependence analysis, but they haven't been implemented in Capella, in ATICA especially. Okay, this is something, again, if the project that we are working on requires it, we definitely do it.
Okay, thanks. A big thanks to you and the speaker for your excellent presentation, and all the attendees for joining us and sharing your time.
Excellent. Well, so thank you all for listening to us.
Thanks, everyone.
Goodbye.
Bye.